Hey there, lovely people. I am Sanjay,
And I'm Ram.
and together we are bringing you something exciting today.
Welcome to Solution Sphere, where we embark on a journey of discovery, innovation, and problem solving.
We are passionate about exploring solutions to everyday challenges, sharing knowledges, and having a blast while doing it.
Whether it's a tech tip, type project, or discussion on cutting edge innovation, we have got you covered.
But this channel is not just about us, it is about you, our community of problem solvers.
So if you are ready to dive into Solution Sphere with us, hit the subscribe button, ring the notification bell, and let's get started.
Let's make this journey together, full of solutions, fun, and endless possibilities. Ram, what you are having today?
So today we are going to have a solution discussion about EVPN and L2VPN interop.
Okay, so
L2VP, EVPN interop with L2VPN based on targeted LTP.
okay, fantastic. So you are going to demonstrate any topology or how it will be? Can you just explain a little bit?
So first of all, we have a topology.
Yeah, I can see that.
So we have a P1, P2, which is connected to a switch in a V shape, which
Mm-hmm.
runs EVPN.
Okay,
From P3 towards P1 and 2, we are running targeted LTP L2VPN session.
okay,
So to achieve this solution, what are the things we are going to go? First, we need to establish a EVPN session between the P's.
okay.
Then we need to establish LDP session
Mm-hmm.
between P3 and P1 and 2.
Okay,
And making a note that P1 to P3 will be the primary, P2 to P3 will be standby.
okay,
So we are connecting one switch behind the V shape and one switch behind P3. It will act as a host. We need
mm-hmm.
to ping end to end to make sure the solution is working fine.
Can you show me the topology again? Okay, so P1 and P2 you are running with the EVPN, and P1 to P3 and P2 to P3 you are having a pseudoware, right?
Right.
Okay, and we want to demonstrate that host 1 will able to reach out to host 2.
Right.
Okay, understood. Okay, thank you.
Let's start with the configuration part.
Okay, and we are you have already configured the L2 VPN, EVPN, BGP neighborship, right? That has been there already. The infra
Right.
is ready. Huh?
Yes, infra is ready.
Okay.
So now we are going to see the configuration on the P1.
Okay.
So first is attachment circuit, which
Mm-hmm.
is connected towards the switch one. So
Mm-hmm.
where we are making it as a L2 transport interface, and then we are going for a EVPN configuration. So when it comes to EVPN configuration, we have to configure EVI and we have to call the attachment circuit into the EVPN configuration.
Okay, one point regarding this L2 transport interfaces that you configure. So encapsulation default, I may use any VLAN also, right?
Right.
I can use the .1 queue, any VLAN, right? 5, 10, whatever I want, right? That is up to the customer too.
Yes, it's up to the customer.
Okay. Then what you did?
Then EVPN configuration,
Mm-hmm.
where we have to configure EVI.
Mm-hmm.
EVI is similar to VFI, what we use in normal L2 VPN, right?
Mm-hmm. Mm-hmm.
And we are calling the interface or attachment circuit which is going to participate in the EVPN, right?
Okay.
And we are configuring a ESI for that. And since it's a multi-home environment,
Right.
this ESI number should be same on both the Ps. I mean P1 and P2.
Okay, okay. The same ESI number we are using and type 0 you are using, right? That means customer can write it own ESI number.
Correct.
Okay,
Also, I'm mentioning it as advertised MAC. So it means with type 2 route, it will carry the MAC.
okay.
Then comes to the L2VPN configuration where
Mm-hmm.
we are using bridge domain. Through bridge domain, we are forming the neighborship. So in this, we have to call attachment circuit, then EVI. By calling these two, we are stitching the EVPN with the attachment circuit.
Okay.
Then we are calling the pseudo wire
Mm-hmm.
towards the P3.
Okay, it is a normal pseudoware, right? The neighbor and
Yes.
pseudoware ID, as simple it is, right?
Yes.
Okay.
Okay. We'll go
Yeah.
to the next. This is on P2.
Okay.
So it is like similar to what we have seen in P1,
Mm-hmm.
like creating one attachment circuit with encapsulation default. Then
Mm-hmm.
on EVPN, creating a EVI and
Right.
also the ESI. And please make a note that the ESI number is unique. I mean, it is same on both P1 and P2.
Right.
And then we are also forming the L2VPN BD,
Mm-hmm.
which includes attachment circuit, EVI for stitching between EVPN and the attachment circuit. Then we are having a pseudo wire running between P2 towards P3.
Yeah, as it is. Right. Right. Okay. Both are similar.
Now goes to the switch one configuration, which is behind the P1 and P2.
Mm-hmm.
Here we are configuring the VLAN and we are assigning a IP for that VLAN. And this VLAN is called as SVI, and that SVI is going to act as a host in our demonstration. And since this switch is connected in a V shape towards the P1 and P2,
Mm-hmm.
so we are calling this VLAN on both the uplink ports. The
Okay.
port gig 111, which is connected towards the P1, and gig 112, which is connected towards the P2.
Okay, so you created one SBI in the switch itself. So instead of a host, you made this particular switch to work as a one of the L3 interface, right? And it will.
Right.
Okay, understood. Okay. But
Now,
anyway, if I'll have a host, then I have to give a VLAN to that interface, which is getting connected to the host.
yes,
That.
just in case if we have a host,
Mm-hmm.
then we need to allow, I mean, we need to allow VLAN on the port where the host is connected,
Mm-hmm.
and we have to configure the IP on the host
Yeah, that
interface, which is facing the switch.
similar to the configuration that you are having with internet, sorry, interface 111, right?
Correct.
Same configuration. Okay, understood.
Now goes to P3. So in the first two cases, P1 and P2, both are XR boxes,
Mm-hmm.
and this P3 is a XE box.
Okay.
So here the configuration will be slightly different, something like we are not creating a sub interface. Instead of that, we will be creating a service instance.
Okay.
So we have created a service instance. In the service instance, we are configuring a pseudo wire towards the P1 and P2,
Mm-hmm.
and we are making sure the P1 is primary and P2 is backup in such a way that we are configuring here.
Mm-hmm.
We are saying it.
Yeah.
We are mentioning the P1's IP here after XConnect. So it means it will become a primary, and as a backup here, we can call the IP address of the P2.
Okay.
And once this is done, now it's time to verify the L2VPN targeted LTP session
Okay.
to see whether the session is up
Mm-hmm.
between the Ps.
Okay.
So now when we check this command, we can see the status. We can see one is up and the other one is IA.
Mm-hmm.
So up means the status is up end to end. IA means it is inactive.
Okay.
Now you can see the state. The
Mm-hmm.
state it shows primary, secondary.
Okay.
The one which is in primary, it goes towards the PE1. The IP address is 172.16.1.1.
Okay.
And the second one, which is the secondary, which is goes to P2 172.16.1.2. You can see the status also, up and standby.
Okay.
Now let's go to the switch 2 configuration. So it's similar to what we have done on switch 1.
Right.
So here also we are creating a VLAN, we are creating a SVI and calling that SVI on the interface towards the P. So
Okay.
this way, this switch will have a SVI and that SVI will act as a host. Instead of connecting an extra device, we are having it like this.
Okay. So here also we are not using any host, separate host. Instead, we are
Correct.
using a SBI for the
Correct.
L3 interface, right? Okay.
Right.
Mm-hmm.
Now comes to verification.
Okay.
So the verification is on a high level.
Mm-hmm.
We should have a end-to-end reachability. To
True.
check the end-to-end reachability, we should able to ping the IPs, SVI IPs configured on the switch end-to-end.
Mm-hmm.
See, in order to check layer by layer, so we
Okay.
have mentioned few things here,
Mm-hmm.
like first checking the layer on the EVPN, then goes to the pseudo wire, then goes to the MAC address verification,
Mm-hmm.
and then VLAN, and finally ping test, so that we will know in each level
Mm-hmm.
things have been exchanged and it is having a proper value.
Okay.
Let's start the first one, EVPN pseudo wire check.
Mm-hmm.
So here this is the command which will show you what is the status of the Ethernet segment.
Okay.
Since it's a multi-home,
Right.
we are seeing two next stops for
Mm-hmm.
a particular ESI, right?
Yes.
That's what we are seeing here, right? And
Mm-hmm.
also here in the operational, we are seeing the status as multi-home single active.
Right.
Since it is mentioned as single active, it means at a time, one of the link can carry a set of VLAN and another link will carry another set of VLAN. That's how it is. And in this case, we have used VLAN 10 and which
Mm-hmm.
is selected on P1, right?
Yes.
So that election detail you can see in the service carving result.
Mm-hmm. As it is even, then that's why it is coming under this interface.
Exactly. So this is a even number VLAN, so that's why it's coming on the P1. If it is odd number VLAN, then it will come on the
P2.
P2. So
Okay.
let's see the P2 output as well, so that it will be easy to compare. So this is a P2 output. In P2, also you can see the ESI and the next stops. We have
Mm-hmm.
the couple of next stops, and the status is also showing as multi-home single active. And now comes to the carving status. In the carving, you can see it is saying not elected for the EVI 10. It
Right.
means only one link is selected, and that is behind P1.
Mm-hmm. It is a
Now,
standby link, right?
yes, this is a standby link
Yeah, for VLAN 10.
for VLAN 10.
Okay.
Whenever the attachment circuit goes down
Mm-hmm.
on the P1, that's when the traffic will get shifted to P2.
Okay.
Now let's go to the additional checks, whatever we have mentioned before. Like first one is to check the pseudo wire status. We can see the pseudo wire status is up.
Right.
This is our P3 IP.
Mm-hmm.
And then the next part is to verify the MAC. Since it is on the L2, and
Mm-hmm.
we have also given advertised MAC
Mm-hmm.
under the EVI. So the MAC address will be exchanged in the route type 2.
Okay.
And that we can see in a MAC table under EVPN using this command, show EVPN EVI MAC. So
Mm-hmm.
this will give you the list of MAC addresses which are getting exchanged on this particular EVI.
Okay.
Here you can see the MAC addresses. You can see the MAC address of the host 1 and host 2.
Mm-hmm.
In our example, it is nothing but the SVI 1 and SVI 2.
Okay.
and what are the corresponding labels for the same.
True.
Now I'm going to the P2. In
Mm-hmm.
P2, we can see the pseudoware status. It is showing as standby, which is as per our design expectation.
Mm-hmm.
The pseudoware should be in a standby state. So it
Right.
is as per our expectation. And also, please make a note that the attachment circuit state is still up,
Mm-hmm.
but it is not carrying any traffic.
Mm-hmm.
It's because it is not this EVI, whatever we are testing, it's not elected by this P2.
Right.
That's why there is no traffic, but still the link is up.
Mm-hmm.
Then on additional check, we are confirming whether any MAC learning has happened. You can see
Yes.
there is an empty table, there is no MAC learning is happened here.
Mm-hmm.
Now, as a final check, we are checking on the P3 as well, whether the pseudoware is fine. Once this is done, we can go for a ping test. With ping, we are able to reach host 1 to host 2 successfully.
Mm-hmm.
With that, the solution requirement has been achieved.
Okay, great. So,
Thanks for watching.
yeah, so before concluding, I just want to know where we can use this sort of solutions. Is it for the OLT, or what you recommend? Generally, what you have seen where it is getting implemented.
Generally, in a V-shaped network,
Mm-hmm.
normally people why go to EVPN is
Mm-hmm.
to achieve all active, right?
Okay.
But in terms of data center, but in
Right.
terms of service provider, we
Mm-hmm.
have mostly single active because we want to have dual path
Mm-hmm.
as a backup,
Mm-hmm.
and still we want to utilize both the links.
Okay.
Wherever there is a condition that we have dual path and to utilize both the links in an efficient way in a service provider environment, we can go with this option. Multi-home is single active.
Okay. Is it a replacement of MCLAG? Can we
Yes,
say?
the reason why we go for MCLAG
Mm-hmm.
is normal VPLS doesn't support active active.
Ah, yeah,
It
that is the
supports
key. Yeah.
only active,
Mm-hmm.
active standby kind of. So, in order to achieve active active with VPLS, we need additional protocols like MC, ICCP, that is MCLAG, or pseudo MCLAG, or we have to go with some MSTP kind of additional protocols
Mm-hmm.
to break the path. I mean, the break the loop,
Ah,
right?
yes, 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 yes. Okay.
With EVPN,
Mm-hmm.
we can achieve active active, and which is again a loop free.
Yeah, true, true. Now I understood. Now I understood where we can use it. Okay, thanks. Thanks for watching, viewers. And if you like it, go for the subscription button and subscribe it to our channel. Thank
And
you.
encourage us to
Yeah,
more to record more videos, and also post your queries.
yeah,
And
that is
if you have
important. Yes.
any topology, if you have any solutions, which if you have any design in your mind which you want to demonstrate by us, please post that as well. We will work on that in coming weeks.
Yeah, exactly, exactly. Thank you. Thank you for watching. Bye bye. Take care.